sealant specialist Rehau has ordered the system testing of its innovative multifunctional sealing tape Isoblocko 1. A test specimen has been set up to see how the seal performs over the long term when installed in practical situations. A PVC window has been built into the test specimen and sealed using Isoblocko 1. Instead of a butt joint, the tape is applied at the corners to form a loop. This helps to ensure that the corner areas are also completely sealed. Unlike similar systems, the Isoblocko 1 can be used on all four sides of the window frame, and it can also be used on a profiled windowsill. This makes the multifunctional sealing tape simple, safe and quick to apply in just a single step. As system developers for sealing products used in the construction sector, for years now we've had our products tested by external agencies to confirm that they comply with the applicable standards. Given that window installations call for seals that will last over a long term, we also have them tested after artificial aging and repetitive stress situations. Only then can we be sure that the required airtightness and resistance against driving rain remain constant over longer periods. After all, our product is expected to perform for many years once installed. Before testing can begin, the ready prepared test specimen is carefully checked by the engineer in charge of the process. For the tests that are to be performed, it's important that the sealing system be carefully installed and correctly mounted. Special attention is paid during the checks to ensure that the corner areas are securely sealed and the distance to the wall is correct. Experience shows us that the faults in the seal tend to appear again and again in the same places. We consider correct application of the sealing system at the corners to be a key factor. Another important point has to do with the joints in the sealing system and the area under the windowsill. What makes the system we're checking here so special is that it can be applied to all four sides of the frame, so it's very important that these aspects are closely checked. The test itself consists of 3 parts and is conducted over several weeks. Firstly, the airtightness of the system needs to be assessed. To do this, smoke is blown into the test chamber so as to immediately show up any leaks. To prevent the window element affecting the outcome in any way, it is given an additional seal using modelling clay. This helps to ensure that the performance of the sealing system being tested is the only thing that affects the results. Once that's done, the measuring can begin. In checking for airtightness, the pressure is gradually increased up to a maximum difference of 1000 pascal at positive and negative pressure. The minimum testing requirement here is an A value of just 0.1 cubic meters per hour and per meter of joint length. Any localized sealing faults, for example in the corner areas, are not allowed. Next, Isoblocko 1 is tested for the resistance it provides against driving rain. Once the rainfall simulator has been turned on, 480 litres of water will be driven down onto the outside of the window every hour through 4 spray nozzles. The pressure is then gradually increased with a view to simulating the effects of wind and rain in natural storm conditions. Only when the outer sealing layer of Isoblocko 1 has been shown to be capable of withstanding the driving rain can the other features of the product, such as airtightness and thermal insulation, be guaranteed. Regular checks are made on the inside of the window to determine whether Isoblocko 1 offers sufficient protection against the driving rain. With the driving rain test passed, the first part of the procedure, testing in an as-new condition, is now over. And the result is clear. Isoblocko 1 stands up to wind and rain just as well as its manufacturer's claim. The second part of the test is conducted in a number of stages over the course of several weeks. During this time, Isoblocker 1 needs to demonstrate that it can stand up to the kind of everyday stresses that a window and its seal will be confronted with over the course of their working life. Key areas to take into consideration include stress caused by changes in the temperature, wear and vibration when the window is opened or closed, and stress caused by strong wind or suction, which can occur during storms. Sensors are attached to the window to measure stresses associated with changes in the temperature. Any movements in the seal caused by changes in the temperature will be shown during this stage. Over the years, window sealing systems have to withstand all kinds of temperature-related stresses. Changes in the season, for example, or in the daytime-nighttime rhythm, constantly lead to changes in temperature that the seal will have to withstand while continuing to perform well. The fundamental suitability of the material is already confirmed through testing in accordance with DIN 18542. During this part of the test, we reproduce changes in temperature ranging from -15 to +60 degrees Celsius in continuously repeating cycles. These tests alone can take up to 14 days. For mechanical stress testing, the test specimen needs to be transported to a special test bed. Mechanical stress on the window joints constitutes a major challenge for the sealant. Only when the product has shown that it can maintain its elasticity over the long term and cope with movements in the joint can bumps and knocks be absorbed without negative consequences for the seal. Once we finish testing against temperature changes, we then move on to continuous performance tests. During these, the connection joints are subjected to dynamic shock loads. Around 10,000 operations are conducted during this part of the testing. All of those tasks simulate things people do with their windows every day, like turning, tilting and closing. The final test consists of checking performance under alternating pressure loads. To do this, a test frame equipped with measurement sensors is attached to the window frame. In this way, even the smallest movements in the window during the tests can be shown up. This pressure suction stress testing helps us to see how factors such as strong gusts can affect a window. Because we want to simulate stresses similar to those the seal will be exposed to in real life, we conduct the test with 200 cycles and up to ±1000 Pascal, equivalent to a wind speed of around 140 km per hour. When you compare the results of the first cycle and the last one, it's clear that there was practically no change in the amount of movement. This concludes the phase of simulating everyday conditions. To flag up any necessary changes or even declare the product a failure, during final testing the airtightness of the seal is checked one more time to confirm that the system continues to provide a reliable seal. In addition, further tests are conducted under simulated conditions of driving rain, during which it's important that no water leaks through the joint. With all the tests now completed, the connections are visually checked for negative changes such as cracking, peeling, or changes in the color or the structure of the material. The tests we conducted on this sealing system have produced very good results. Even after being exposed to all those stresses, the overall condition of the test specimen remained unchanged. We were also able to show how airtight it was and how well it stands up to driving rain, well above 1000 Pascal in this final check.